At first glance, this looks like a desolate wasteland. But beneath the cracked earth, life is waiting.
How does a frog bury itself underground for months and come out alive? No water, no rain, cracked earth for as far as you can see, and somewhere beneath your feet, a frog is waiting it out. Let's set the rules first. This isn't a nap. It's not hibernation either, not the way a bear does it. This is something stranger, an animal built almost entirely of water, choosing to seal itself inside a coffin of dried mud, for months at a time, in a landscape with nothing to drink. So how does it not just dry up and die? Let's find out. Start with the setup. In the deserts of Australia and the savannas of Africa, the dry season can stretch for 6 months, sometimes longer. No rain falls. Temperatures on the surface can climb past 40 degrees Celsius. Any animal with wet, permeable skin should be finished within days. Frogs breathe partly through their skin. That skin needs moisture to work. Take away the water, and you take away the frog. That's the rule every other amphibian has to live by. This frog breaks it. Meet the water-holding frog, Cyclorana platycephala, and its cousins across the world's dry regions, including the African bullfrog, Pyxocephalus adspersus. When the rains stop and the ground begins to bake, these frogs don't wait for trouble. They dig. Using the hard, spade-like edges of their back feet, they burrow straight down, sometimes over a meter deep, chasing the last traces of moisture in the soil. Then something remarkable happens. The frog begins to shed. Not fur, not scales, skin. Layer after layer, the frog sheds its own outer skin, but instead of leaving it behind, it wraps each layer around its body like tissue paper. Over days, this builds into a cocoon, translucent and tough, sealing the frog inside almost completely. Only the nostrils stay exposed, 2 tiny openings to the world above. Biologist Kelly McCartney, who has studied burrowing frog cocoons in Australia, has shown that this casing can cut water loss by more than half compared to an unprotected frog in the same soil. That's stage 1. The frog has built its shelter, but a shelter alone doesn't explain how it survives what comes next. Because sealing in moisture only slows the clock, it doesn't stop it. 6 months is a long time to hold your breath on hydration. So the frog's body starts making chemical changes most animals could never survive. Its metabolism drops to a fraction of normal, sometimes below 20% of its active rate. Heart rate slows. Movement stops almost entirely. The frog is, for all practical purposes, suspended. Research led by physiologist Philip Withers, who has spent decades studying Australian desert amphibians, found that some water-holding frogs can survive losing close to 50% of their total body water and still recover completely once rain returns. A human losing even 10% would already be in a medical emergency. How is that gap even possible? Here's where the science gets stranger. Frogs in extended dormancy raise the concentration of urea in their blood and tissues. Normally, urea is a waste product, something your kidneys are built to flush out immediately. But for a burrowed frog, it becomes a tool. High urea levels change the internal chemistry of the frog's cells, helping hold on to whatever water remains and stabilizing proteins that would otherwise break down under stress. It's the biological equivalent of switching your car onto reserve fuel and then rebuilding the engine to sip that reserve for months instead of hours. This single adaptation is one of the reasons desert frogs can outlast almost anything else living in the same soil. Now raise the stakes further. It isn't just about water, it's about starvation too. For half a year, the frog eats nothing at all. No insects, no prey, nothing crossing its path underground. Every gram of energy it uses has to come from fat reserves built up during the brief wet season before the ground dried out. Ecologists studying Pyxocephalus adspersus in southern Africa have documented individuals losing significant body mass across a single dry season while their organs and tissues remain largely undamaged, a level of controlled, reversible wasting that would be catastrophic in most vertebrates. Muscles in long dormant animals usually break down fast without use. Think about what happens to an astronaut after even a few months in zero gravity, or a hospital patient after a few weeks of bed rest. Muscle wastes away fast, and it takes real effort to rebuild. A buried frog faces that same problem for 6 straight months, with no physical therapy waiting for it on the other side, only a hard wall of dried soil. And yet it doesn't collapse the way logic says it should. Somehow it keeps its tissue chemistry stable enough to snap back into motion the moment conditions change. There's also the matter of oxygen. Buried more than a meter down, sealed inside a cocoon of its own skin, a frog isn't exactly breathing freely. The 2 exposed nostrils allow a slow trickle of air to reach the lungs, but with metabolism running at a fraction of normal, the frog barely needs it. Researchers studying estivating amphibians have found that this combination, a nearly sealed body and a metabolism idling near its floor, allows gas exchange to keep pace with demand even through months of near-total stillness. It's a balancing act. Slow the engine down enough, and even a tiny trickle of oxygen becomes plenty. But surviving underground is only half the challenge. Timing is the other half, and getting it wrong is fatal. Dig too early, before the surface has really dried out, and the frog wastes precious energy and moisture reserves for nothing. Dig too late, after the soil has already hardened past a certain point, and there may not be enough give left to burrow deep enough to escape the heat. Field studies on burrowing frogs suggest they respond to subtle cues in soil moisture and temperature days before conditions become lethal, essentially reading the landscape and making a life-or-death call before a human observer would notice anything has changed. Get that call wrong, even once, and there's no second attempt. And burial itself carries its own risks. A meter of packed soil might sound like a fortress, but it isn't an impenetrable one. Burrowing predators, from monitor lizards to certain mammals, can and do dig frogs out during the dry season, cocoon and all. Drought years that run longer than usual can also push a frog's water reserves past the point where even a slowed metabolism can compensate. Researchers tracking desert amphibian populations across multiple seasons have found that survival rates drop sharply in years when the dry period extends well beyond its typical length, a warning sign that's becoming more relevant as climate patterns shift and dry seasons in some regions grow longer and less predictable. In other words, this entire system is a finely tuned bet against a fixed clock, and that clock is not guaranteed to stay fixed. And that moment does come. The first hard rain of the wet season doesn't just fall, it drums. Water seeps down through the cracked earth, reaching the buried frog. The moisture triggers something like an alarm. Within hours, sometimes even less, the frog begins pushing itself upward, breaking through soil that's been packed solid for months. The cocoon that once sealed in every drop of moisture now splits apart, no longer needed. Metabolism surges back toward normal. Muscles that sat motionless for half a year suddenly have to fire again, strongly enough to dig, to move, to call. Because that's the final twist. These frogs don't emerge quietly. Within a day or two of surfacing, many species are already calling for mates, racing against a wet season that might only offer a narrow window of standing water for eggs and tadpoles to develop before it dries out again. The same animal that spent 6 months nearly motionless underground now has to sprint through an entire reproductive cycle in a matter of weeks. There's no easing back in. There's no recovery period. Survival was only step one. So how does a frog survive underground for an entire dry season? Not through a single trick, but through a chain of them, stacked on top of each other. A cocoon built from its own shed skin. A metabolism that can idle for months without failing. A waste chemical repurposed into a lifeline. And a body that can lose half its water and still spring back to full function the moment rain returns. It's not luck. It's an entire physiological toolkit evolved over millions of years for one goal, outlasting a season that should kill it. And maybe that's the part worth sitting with. We tend to think of survival as strength, speed, size. The fastest animal, the biggest predator, the toughest fighter. But somewhere under a sun-baked field right now, an animal smaller than your fist is proving that survival can also look like stillness, patience, and a body engineered to wait out the worst the world can offer. It's not built to fight the drought. It's built to outwait it, to let months pass without panic, without wasted movement, without giving up. There's something almost familiar in that, even if it doesn't look like it at first. Every one of us has faced a stretch of time we couldn't fix or outrun, only endure, a difficult season with no clear end date, where the only real strategy was to hold steady and wait for conditions to change. The frog doesn't have hope the way we understand it. It has biology, urea buffering its cells, a metabolism idling low enough to stretch 6 months of stored energy, a cocoon built from nothing but its own skin. But the outcome looks a lot like patience anyway. So the next time you cross a stretch of dry, cracked earth, remember, there might be a whole life underneath it, holding its breath, waiting for the rain.